Hi everybody, in this video we are going to see finally the video that controls the position of the robot. The final idea is to find or implement a control that helps us to achieve a point in the space. Finally, we watched in the last videos a lot of topics that help us to achieve to design this video and that was our idea, and let's go to see that how to implement it. Please like, share and subscribe to my videos. It helps me a lot to make videos like this. Thank you so much. Okay, firstly, we'll begin with the car. The car is placed in a XY position. This is the place or the position of the car. And you know that this car has a direction. This direction is measuring by an angle. That angle is 5. This is the orientation of our car. But we want that this car achieve a point in the space. That point is X desire, Y desire. This is the point that we want to achieve with our car. This is the trajectory that the car has to describe. If we have a trajectory, we could describe what is the angle desired or phi desired, and this angle we could calculate with this equation that is very simple, that phi desire is a inverse tangent that g desire minus g over x desire minus x, and that is the equation that helps us to calculate the angle desired for the trajectory that the control have to describe. Okay, in this part, let's go to aggregate that code, that lines of code. The first thing is this is aggregate the desires variable, the x desire, the y desire, and the phi desire, that is the angle desire. That you could see that those are our calculates. That is very simple, and it's very important that you know that phi desire, that the angle desire, is calculated in the first part of the variables, and in the code, in the loop code, we have to aggregate, we have to add this line of code. Another important part of this video is that we have to control a variable. And we have the linear velocity and the angular velocity. That linear velocity will be constant in this case. In this case, we don't control the linear velocity, but the angular velocity is variable. And that helps us to control our angular velocity. Then the objective of this video is generate a control that achieves a point, only control the angular velocity. This is the key. In the code, we are going to add the line of code that defines the linear velocity, that is defined by the velocity of the right wheel, the velocity plus the velocity of the left wheel over 2, that is a mean of the velocities. This is the velocity, but in this video we know that this variable is constant. In this part of the code, we have to add the lines of the parameters of the car. In this part, we add the diameter of the wheels and the length, the distance between wheels. Those parameters are very important, and the linear velocity and the angular velocity is added in this part too. Those variables are really important in this code. So we want to design a control, we have to define a kind of error. This error is generated like the difference of the angle phi desired minus phi is equal to the error. In this part we add this line of code that is the error that is defined like the phi desired minus phi is equal to the error. There is the difference between the angles. Did you know that this error is the key of our control? You have to take in account that, and we have to generate this variable in the first part of the code. You know it. Okay, let's discuss some things important in this control. The first one is the linear velocity is constant and the angular velocity is variable. We know that the linear velocity is constant because we are going to define a velocity like 1 meter by minute, but the angular velocity is the key of this controller. We want to achieve an angle, and the cars, if the velocity, the linear velocity is 0, the cars only rotates to the desired angle, and it achieves this angle, this reference, and the cars stop it. The cars only have to achieve this angle and the car stops. But if we make that the linear velocity different to 0, they has to pass over the point, the desired point, if the desired point is far enough of our trajectory. But you have to take in account that our car doesn't try to achieve the desired point. It only finds the desired points if the point it's in his trajectory. But it could have this situation. The point could be near to the car. Then the car tries to achieve the point, but it achieves the angular, the position of the angle, and he passed the desired point. He passed it because it don't have the necessity to achieve the controller don't achieve the point. The controller only needs to achieve the desired angle. And this is very important. You have to take in account in this controller. This is a proportional controller, so we generate the gain of the controller in the variables. So in this part we add the line of code that controls the angular velocity. The angular velocity is measured by this equation that is the right velocity minus the left velocity over the length of the wheels plus kp plus by the error. That's kp by the error is the controller that we are going to use to control the angular velocity of our car. Another variable that we use in this program is that PWM R and PWM L. Those variables are the signals that applies to the PWM of the motor, the right wheel, the PWM right, and the PWM left. Those are the variables that our controller calculates. In this part of the program, we generate those variables. We add the line of code that calculate the PWM of the right wheel and the PWM of the left wheel. We use the equation that we watched in the last videos. That is the velocity plus the omega velocity by the length of the wheels over 2. This is the PWM right is with a plus, and the PWML is with a minus, the same variable. Those are the equation that we watched, that we designed, that we found in the last videos. I recommend you, if you don't understand that, tries to watch those videos. Those equation was found in the last videos, developing the model of the car, and we developed those equations. Those equations are very simple, and you could watch it. Another thing that we could define in this part is the max and min signal that we could use in PWM. We are going to define the PWM max and min. Those are the saturation values, and those are really important for our program. Those saturation values are used with those sentences. In this sentence, you could see that those are like if a signal goes higher than the max value, it generates that the saturation works, and makes that it achieve the roof and achieve the floor. And those are the variables that we use to control our project. With this line of code, it is a if. This if is the convergency line of code. You could see that if this if tries to watch what are the position of the rover and the desired position. If we have an error in the desired position less than a value, you could see the absolute value of x and the absolute value of y. If we have this convergency that help us to achieve the point, the car stops. But if we don't achieve the real position, the car stops. So with this line of code, we could prove our program. You could see that the blue line is the saturation of one signal, and the red line is the saturation of the other signal. The signals that we are watching right now are the PWM of the right motor and the left motor. Okay, and the last part of the code is assigned to the linear velocity a constant value. You could watch that this implementation use the equation that we watched in the last videos. But right now we are defining this velocity to a constant value. This constant value is a value that I gave to this equation because it affects highly the PWM of the right wheel and the left wheel, and so like this I achieved to a 40 value because my motors start to move it with those values. You could watch that I change the values that send the Arduino, and we are sending the X and Y position that the car's methods. And you could watch that image that is generated by MATLAB program. You could see that this program, that this variable that the car tries to achieve the desired point. You could watch it right now. We are going to plot a variable with a circle red, and that is placed in a position 0, 100. And if we make the play, we use the play button, you could watch that the car tries to achieve that point, but it is difficult. It's difficult, but it could change the KP gain of the control and tries to make it to reprogram our Arduino, and you could watch with a little value of the gain of the error, the control don't works. If I change another in another way that variable, you could watch that the car tries to achieve the point. You could watch the oscillation, and you could watch that the signal tries to achieve the point, the desired point. In this part is implemented the control in the car, but you could watch that the car tries to achieve the point in the space. You could watch that the car moves slowly, but it tries to achieve the reference. And sometimes I have to push the car, that is because I don't configure right enough the control of the car, but I could increase the linear velocity, and that helps that the motors move faster. But you could see that the cars achieve the reference, and that is the idea. In this part, we change the reference. In this case, I change the reference to the desired point, to the reference x coordinate to 100 and y coordinate to 100. This is the point that I want to achieve. So let's see the graph that generates that control. You could watch that the car tries to achieve that reference, and that tries to make it better in every time, and that is very very good. You could watch that the idea that the movement of this control it has some oscillation, because the car is not on the floor, it don't move his own weight. That you could watch that the car tries to achieve very very good. And I'm going to try to change the convergence limit to 10 centimeters, and you could watch that the car stops in the point. And right here, if I put the car on the floor, you could watch that the car don't have the oscillation. Why the car don't have those oscillations? Because these oscillations are because the motors don't have to move the the weight the weight of the car, and you could watch that it moved really smoothly around the floor, and that is the idea of this control. The cars move really slow, but it achieves the reference, and that was the real idea. And this is the idea of this video. The video, we try to achieve a desired point, and we did it. You could watch the something like a simulation, and in MATLAB that is not a simulation, because those are the measurements that the cars are making, but it has that response because the car don't have to move his weight. But this is the idea. I really enjoyed making this video. I really like if you support me liking, sharing, and subscribing to this channel. I really like to make this video. Thank you very much, and we will see you the next time. Bye bye.